Hello students, greetings to you all. Hope you all are safe and doing good. So from last class we started with the new unit which is unit 3 fluids. So this is the continuation of unit 3 which is part 2. So let's start with the motivational quote for the week. Success is a vehicle which moves on a wheel called hard work. But the journey is impossible without fuel called self-confidence. I repeat it. Success is a vehicle which moves on a wheel called hard work, but the journey is impossible without fuel called self-confidence. Yes, my dear students, so hard work and as well as the self-confidence is very, very important to lead a successful life. So with this quote, we move on to the class. Before that, we recap what we learned in previous classes. So we started with Unit 3 fluids and the two main important physics terms which we dealt in previous class was thrust and pressure. So what is thrust? It is a perpendicular force and its SI unit is Newton. What is pressure then? Pressure is nothing but force per unit area and the unit is Newton per meter square. The formula for pressure is thrust by area of contact. Factors determining pressure in liquid. There are three factors which is depth, density and acceleration due to gravity. So pressure due to liquid column we saw and that pressure is nothing but rho GH. And pressure is directly proportional to height or depth of the column. I hope you are all clear with previous classes. So now we'll move on to the today's session. The topics to be concentrated in this session are Pascal's law, relative density, buoyancy, and Archimedes Principle. And these four important topics are very, very important in this unit. So listen to this class keenly. So let's start with an activity. In previous class, I gave you a homework regarding this. So how many of you tried? I'm not sure. So I hope my students would have tried this activity at your home. If not, see this video. You will get an idea about it. Yes. So this is nothing but take a plastic bottle, put holes in the surface of the bottle. Okay, put 5 holes. Okay, put 5 holes, and if you pour the water into the bottle, the water pours out with uniform speed. Okay, this pressure is transmitted equally throughout the liquid in all direction. Yes, and this is the principle behind this is Pascal law. So what Pascal states is the external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. So this principle is named after Blaise Pascal. He is a French mathematician and physicist. This principle is applied in various machines used in our daily life. Said that this principle is applied in various missions in our day-to-day life. Here comes one important mission. Okay, this Pascal law became the basis for one of the important mission ever developed, which is nothing but the hydraulic press. So this cross-sectional area shown here, it consists of 2 cylinders of different cross-section areas are fitted with pistons of cross-section area A and capital A. Okay, the object to be lifted is placed over the piston of large cross-sectional area A. The force F1 is applied on the piston of small cross-section area small a. the pressure P produced by a small piston is transmitted equally to large piston and a force F2 acts on A which is much larger than F1. So this is a hydraulic pressure, and yes, so pressure on piston of small area A is given by, pressure is nothing but force per area, right? We saw in previous video. So since it is considered as F1 and A1 of small cross section A, we'll take it as P is equal to F1 by A1. And next, applying Pascal's law, the pressure on large piston of area A will be the same as that of the small piston. So therefore, P is equal to F2 by A2, which is the large cross-sectional area, capital A, F2 by A2. Okay. So when we compare equation 1 and equation 2, we'll be getting as F1 by A1 is equal to F2 by A2. From that, we can conclude that F2 is equal to F1 by A1 into A2, right? So you'll be getting this formula. The ratio A2 by A1 is greater than 1. Since the ratio A2 by A1 is greater than 1, the force F2 that acts on the larger piston is greater than the force F1 acting on the smaller piston. Hydraulic systems working in this way are known as force multipliers. So now let us focus more on density. So what is density? It is a measure of how compact the mass in a substance or object is. And let's see the definition. In the same given amount of space, if there are more things, we say that is denser. Yes. And density is nothing but mass per volume. It can be calculated by the mass divided by its volume. And the SI unit of density is kilogram per meter cube. Then, I would like to ask you a question. Have you noticed that when we put wood in the water, it floats, whereas when we put the pin in the water, it sinks? Have you ever noticed that? If you would have noticed that, you would have arised a question: why does the wood float and the pin sink? And the answer would be yes. So wood float on water because density of the wood is less than the density of water. But density of the metal pin is greater than density of water. Though it looks tiny, there is more mass per unit volume as compared to water, so the pin sinks whereas the wood floats. So this would be the best answer why the wood floats and the pin sinks. And if density of an object is less than the density of liquid, then the object will float. If density of object is greater than the density of liquid, then the object will sink. So hope you are clear that how the object sink and how the object floats. So this is the main reason. So density plays a major role in this flotation and sinking. Okay? Yes. So now we'll see relative density. Comparing the density of one thing to the density of another. Okay, but related to what? Related to density of water. Density of an object versus the density of water. So this comparison is known to be a relative density. So relative density of a substance is given by density of the substance by density of water. So unit of relative density is, it has no units. So let's see with an example. So here they have given density of water to be 1000 kilogram per meter cube and density of silver to be 10,500 kilogram per meter cube. So relative density of silver is nothing but density of silver by density of water. So when we calculate like this, so density of silver, we know that 10,500 kilogram per meter cube by density of water is 1000 kilogram per meter cube. When we calculate it, we'll be getting 10.5. Therefore, it sinks. So mathematically, if relative density is greater than 1, the object sinks. And relative density which is lesser than 1, then the object floats. So relative density of silver, we saw that it is 10.5. Therefore, it is greater than 1, so object sinks. Hope I'm making it clear to you. So next we see float or sink. So whether an object will sink or float in a liquid is determined by the density of an object. That's what we saw right now, right? Yes. And if the density of substance is less than the density of the liquid, it will float. For example, a piece of wood which is less dense than water will float on it. Any substance having more density than water, for example, a stone, will sink into it. So now let us see the application of principle of flotation. So first we are going to see what is hydrometer. So hydrometer is an instrument which is used for measuring the relative density of liquid directly. So this is a picture of hydrometer. This is how it looks. And it is based on the principle of flotation, that is, weight of liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. So, hydrometer consists of a cylindrical stem having a spherical bulb at its lower end and a narrow tube at its upper end. The lower spherical bulb is partially filled with lead shots or mercury. This helps hydrometer to float or stand vertically in liquids. The narrow tube has markings so that relative density of the liquid can be read directly. So here the level of the liquid rises and reading is noted. So the level of liquid touching the tube gives the relative density of the liquid. And next we are going to see lactometer. So one form of hydrometer is a lactometer. It is an instrument used to check the purity of milk. So the lactometer works on the principle of gravity of milk. And the pure milk, the reading would be 1.035, and if the water or impure milk, it would be 1.015. So pure milk ranges from 1.03 to 1.035. And this is how a lactometer works. Inside the test tube, there's a milk, and lactometer is kept inside the milk, and it shows the reading. So the lactometer consists of a long graduated test tube with a cylindrical bulb with a graduation ranging from 15 at the top to 45 at the bottom. And test tube is filled with air. This air chamber causes the instrument to float. And the spherical bulb is filled with mercury to cause the lactometer to sink up to the proper level and float in an upright position in the milk. So inside the lactometer, thermometer is there, and it is extending from the bulb up into the upper part of the test tube where the scale is located. And the current lactometer reading is obtained only at the temperature of 60 degrees Fahrenheit. A lactometer measures the cream content of milk. More the cream, lower the lactometer floats in the milk. The average reading of normal milk is 32. And next topic we are going to see is buoyancy. So what is buoyancy? We already saw that the body experiences an upward force due to the fluid surrounding when it is partially or fully immersed into it. And we also know that pressure is more at the bottom and less at the top of the liquid. This pressure difference causes a force on the object and pushes it upward. This force is called as buoyant force, and the phenomenon is called as buoyancy. So now let's see with a small example. So you would have noticed that when you put a ball in the water, you just need to pressurize it to go inside, right? You need to push the ball inside the water, then only gets immersed fully. So, and when you release your hand, it just again turn floats in the water. So this would be the best example for buoyancy. Yes. And the tendency of a liquid to exert an upward force on an object placed in it is called buoyancy. It is the main reason why we swim and ships float in water. And this is the gravitational force and the buoyant force which is given here. Objects of density less than that of the liquid float on the liquid. The object of density greater than that of a liquid sink in the liquid. So this is what we saw in floating and sinking process. Next important term we are going to see is Cartesian diver. Cartesian diver is an experiment that demonstrates the principle of buoyancy. So it is a pen cap with clay. So the Cartesian diver contains just enough liquid that is barely floats in a bath of liquid. Okay, its remaining volume is filled with air. When pressing the bath, the additional water enters the diver, thus increasing the average density of the diver, and thus it sinks. So these divers are called to be Cartesian divers. So this is how the experiment looks like, a pen cap and a modeling clay. So the plastic bottle, in plastic bottle you are just going to insert this Cartesian diver. First upper part of the cap is filled with air. While pressing the bottle, the water goes in and buoyant force drops. Then it unable to support the weight of the cap, so it sinks. And next important term we are going to see is Archimedes Principle. So let us see with a short video. Listen it carefully, children. So this is an history of Archimedes Principle.
Then you have a beaker filled with water and you put your index finger inside it. You'll observe that the water level rises slightly. You put in 2 fingers, the water level rises a bit more. And now when you put in your hand up to the wrist level, you'll see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this thought in mind. We'll come back to it soon. In our previous videos, we've seen that when an object is placed in or on the fluid exerts a buoyant force on it which acts upwards. The Archimedes principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kg solid object and suspend it by a spring balance. The balance will reach 5 kilograms. Let this be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is. And we keep a small container under the opening. Now slowly lower the solid object into the water and you'll see that the reading will be lower number as compared to the previous case. Why is that? It's because of the buoyant force acting on the object. You would have also noticed that some water was displaced. Now with this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That's the Archimedes principle. When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Where is this principle applied? Can you think of examples? How do you think large steel ships float? It's simple. If the weight of water displaced by the vessel below the keel is equivalent to the vessel's weight, then everything above the keel will remain afloat. That's because the water too applies an upward buoyant force on the ship, which is same as the weight of the water displaced by it.
Yes, and this is what Archimedes Principle. So, our ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. And when he got in, he realized that the level of water went up. And that's how he found Archimedes' principle. So the fluid exerts a buoyant force, which is acting upwards. The buoyant force applied by the fluid is equal to the weight of the displaced fluid. And when an object is immersed fully or partially in a fluid, the upward force applied by the fluid on an object is the same as the weight of the fluid displaced by the object. So this is what the statement of Archimedes' principle. And so we have come to the last topic, which is laws of flotation. So there's two laws of flotation. First one is weight of a floating body in a fluid is equal to the weight of the fluid displaced by the body. So we have seen many examples regarding that, right? And the second law is center of gravity of the floating body and the center of buoyancy are in same vertical line. So the point to which the force of buoyancy is supposed to act is known as center of buoyancy. And that's it, my dear students. So that's it for today's class. Can we all have a quick recap of what we learned today's class? So yes, the main important thing we learned is the Pascal law. The law states that the external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. And another principle which we learned in today's class was Archimedes principle. So what does Archimedes principle states? When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. So for your follow-up work, I'm going to give you a small activity. So listen to this carefully in this activity and try it out at your home. So yes, so try it out at your home. This is a very simple experiment. So if you have a syringe and this hose at your home, or it is very cheap only. So if you can buy, and you can do it. Okay, children. So once you have done, take a picture of it, take a small video. Okay, take a small video of it and upload it in Google Classroom. So thank you so much, children. Thank you so much for listening patiently. Stay home, stay safe. May God bless you.